So right now I'm going to talk about multiplexing and specifically using it with Arduino and 7-segment displays. So a 7-segment display, well in this case it actually has 8 segments if you include the decimal place. Basically there's 8 negative pins or cathodes and then 2 anodes which are actually internally tied together. So basically each of these pins on the back, with the exception of the 2 in the middle, are the cathodes on one of these segments, and if you were to just tie the anodes to positive and the cathodes to a pin on your Arduino, you could control this display. Now obviously you want a current limiting resistor in there somewhere, but basically that's how that works. So problem with that is if you have 8 segments for each display, then once you have 2 displays, for example, then you're going to have 16 pins that you have to control. Then when you have 3 displays, you're going to have 24 pins that you got to control. So the problem is the Arduino only has 14 pins that you can actually control on it. Normally, I guess you can control the analog ins too, but traditionally you're only using 14 pins that you control. So with that, it's a little bit of a challenge in order to use these kinds of displays. If you're not planning on using multiplexing, you'll either have to daisy chain multiple Arduinos together, or you'll have to use an Arduino Mega or something like that. So multiplexing is using less pins to control more pins somewhere else. So basically we have in this example, we're just scrolling through the display, so all of the pins for each segment are tied together to the next display over. So you can see on here, so for example, all the A segments are tied to the next A segment over on the other display. So if all the anodes were turned on, or sorry, if all the anodes were tied to 5 volts, then all the displays would show the same number all the time. But then what we do is bring out the anodes to a PNP transistor, and then we turn on each display individually. Now we're scrolling through the displays like so, and basically when you turn it up really fast, you can scroll through it so fast that your eye can't even tell that it's being scrolled through and that the display is not on all the time. So the camera doesn't really portray it the way that you would see it with your own eyes. But at a certain point, you'll be scrolling through it right about there. It's when I'm looking at the display with my own eyes, I can see the number clearly, but it's obvious it's still flashing. And then once I increase that further, all the way to the threshold that I have set there, you can see it appears as if it's on solid when it's actually flashing between them. The camera has a little bit of a flicker there. It's not actually doing that. It's to your eyes it looks like it's on solid. So that's multiplexing, and basically, like, there's many different purposes that you can there's many different applications for this. So a good example is 7-segment displays in a clock. This clock will have multiplexing on it, and one of the ways that I can tell that this clock has multiplexing is if I go to somewhere where I can set the time and I hold down one of the buttons. I don't know if the camera will be able to pick it up, but you'll notice that the other numbers that aren't changing are slightly flickering between brightnesses, and basically the reasoning for that is the amount of current being drawn by the other segments in the display is changing. So it's actually changing the brightness in the other segments, and that's a clue that you can use that it's not just directly being driven, it's actually being multiplexed. So so that's one application of this. There's multiple different applications, especially in LEDs. Like if you're using LED cubes and things of that nature, there's so many ways that you can use this. So that's my introduction to multiplexing.